what I say, this is the sodium channel at the active state, and this configuration is something like that. Is activation gate is very fast to open, but inactivation gate, which is previously like open, it will start to close, but its speed is less than this one. So in this time is a very fraction of the seconds. In this time, sodium will rush inside the cell. Sodium will rush inside the cell. There is a multiple, many channels present in the cell membrane that it will bring sodium inside the cell. Again, this is the resting state when there is no stimulus, and the sodium channels activation gate is closed and inactivation gate is open. This is the resting state when there is no stimulus, there is no potential. Whenever I stimulate the nerve cell or any cell which is excitable cell, this is only nerve cell or the muscle cell. If I stimulate this thing by any mean, the sodium or positive ions come inside by the mechanical channels, taking the RMP up to the threshold value. If this is accomplished, then at the threshold value, suddenly sodium channels, or we can say the cell membrane, is fully permeable to the sodium, which is previously impermeable because there is no stimulation. Now what happens, these positive ions come inside and make the cell membrane neutralize, and then up to 0, like minus 92, somehow this will become minus 60, then somehow minus 40, then somehow minus 10, and up to the 0, and sometime little bit overshoot also. You can say the positive 20 and the positive 65. Positive 65, remember, this is the equilibrium potential for sodium. Before reaching the equilibrium potential for sodium, suddenly the sodium gated voltage channel will become closed, like this is the state, this will open and this will close. Now again, the third configuration of the sodium channel, this is very important. This is inactive state. This is inactive state of the sodium channels. Remember, now again look what I mean. Activation gate, inactivation gate. During the resting cell, the sodium channel configuration is something like that. Activation gate is closed and inactivation gate is open. Whenever the stimulation approaches and the threshold value achieved, then the sodium channels, sodium voltage gated channels, sodium voltage sensitive channels will suddenly drastically open. That the configuration something like it, that the activation gate suddenly fastly open, and the inactivation gate, which was previously like this, it is moving to close but slowly. Then the sodium comes in, enough sodium come inside that it will success to achieve the RMP to neutralize at threshold value early, and then it will more neutralizes the cell membrane up to minus 60, 40, 10, 0, somehow overshoot the 0 and touches the positive 20, and before reaching to the equilibrium potential for the sodium, it will stop. Sodium channel will inactive, like the inactivation gate close and activation gate of the sodium will open. This is the inactive state. When this state is approaches, like when this point will achieved highest, this is known as depolarization, like the cell membrane is becoming depolarized. First of all, the cell membrane internally polarized, but now we can say the positive cations coming as the sodium, it depolarizes the cell internally. Whenever it reaches its maximum capacity, then sudden the sodium channels off or inactive, then another channels will open. These another channels will open, and these are the potassium voltage gated channels. Potassium voltage gated channel, and potassium will not come inside. Potassium will move outside because it is present inside more. So potassium will move outside, bringing again the cell membrane polarized state. So we can say cell membrane repolarized. Cell membrane is repolarized. Listen very carefully again. What's happening? In this is the resting circumstances. Whenever I stimulate the nerve cell, there's little sodium trickling inside, bringing the RMP up to the threshold value if this is enough stimulus. So threshold value is achieved. As far as threshold value is achieved, suddenly sodium gated channels open. Sodium gated channels open, sodium rush inside the cell, bringing the threshold value like, or we can say bringing the resting cell up to the neutralizes it and depolarize it up to the positive, somehow positive 10, 20, 25, 30. Before reaching the equilibrium potential, the sodium channels will close. When sodium channel will close, potassium channels will open. Potassium channels open, like potassium will start to moving out. Again, potassium also move out from the leak channel, and maximum amount of potassium will also move from the voltage gated channels. So again, it re-establish the electronegativity of the cell or resting state. We can say cell will become repolarized, but there is a delay in the closing of the potassium channels, potassium voltage gated channel, because these are the all the time open. There is a little delay. So the result of the delay, that this is somehow more electronegative than the RMP, than the resting membrane potential, and it will then recover it. Okay. Potassium gated channels open, potassium will moving out, making the cell membrane again polarized, or we can say this is depolarized, but there is a delay in the closing of the potassium channel. Ideally, they should close at this level if you are studying the RMP, but of course there is a delay, and then it will more shoot as electronegative more than the, if we can say hyperpolarized. This is hyperpolarized, but then potassium voltage channels are also closed, and then it will again established at the RMP. This is recovery phase. This is the recovery phase. So this is the action potential generation. Actually, how RMP converted into the RF. This is a very simple. If I put it in a nutshell, it is simply that during the RMP, cell is inside become more electronegative, and during the action potential, cell inside become the more electropositive. One thing, another contrast. During the resting membrane potential, cell is only permeable for the potassium. Potassium leaky channels will open, because there is a potassium voltage gated channels are also present, but during the resting state, voltage gated channel always remember off. During the RMP, there is no voltage channels open. So in the RMP, the cell membrane is only permeable for potassium, but in the action potential, cell is also permeable for the sodium, and when the sodium reaches up to this maximum depolarizing state, then the sudden sodium channels will off, and the potassium channels, potassium gated channels or voltage gated channel will open to again establish the repolarization of the state. But there is a delay in the closing of the potassium channels, that it will shoot out from the RMP and hyperpolarize, but then there is a closure of the potassium channel, and then it become again electro negative and recovery phase, and the stating the RMP, resting membrane potential, until if there is again next stimulus, there is again action potential. This is action potential. Now we will see how action potential propagated. Actually, what is the nerve impulse? Now it is the time to reveal. Nerve impulse, simply the electrochemical changes travel across the cell membrane, across the membrane of the neuron. Now just pause. This is the neuronal cell, isn't it? This is segment number 1, this is segment number 2, this is segment number 3, and this is segment number 4. Remember, neuronal segments are divided into 4 parts. One is the receptive segment, This is include the purely include the cell body and the dendrons. Okay? And then we have the conductive, you can say the receptive segment, and then there is a initial segment. Then there is a initial segment. Initial segment primarily comprised on the axon hillock. Axon hillock is the part from where the axon is start. Look carefully. And then there is a conductive pathway, like conductive segment, and again at the end there is a terminating segment. Actually, these are not so much important. Now listen. Earlier state, when there is a cell resting, there is a negative inside. And there is a positive outside during the resting state, as we have discussed in detail previously, isn't it? Now, what happens? If I stimulate at this point, segment number 1, if we stimulate at this point, what happens? Sodium will rush inside. inside, making the cell what? Positive, making the cell positive, and outside it will become, as compared to internal, it will become electronegative, because sodium comes in. And again, if sodium comes in electropositive and then suddenly sodium channels off and potassium will bring out, and it will again convert in this configuration, internally negative, externally positive. But when sodium comes in, it will move and stimulate nearby adjacent area, which is previously again inside negative and externally positive. And little sodium which comes inside, it will trickle out in the adjacent area and stimulate there this area, and again the sodium channel open and it will become positive inside and negative outside. Again these sodium which come inside, it will trickle in the adjacent area which stimulate this area, and sodium channel will open and again depolarizes this segment, and again sodium will trickling the adjacent area and this side will depolarize again. Depolarize means the positive ions inside. So what we have seen, what does it mean? Actually there is a wave of depolarization across the cell membrane. There is a wave of depolarization, like sodium comes in and making the neutralize the electronegativity, depolarizes the membrane, and these sodium trickling inside or adjacent nearby areas again and depolarizes this area, and then the sodium which comes inside at this point, it will depolarize the next area, and you can say the depolarization, when this area will depolarize, this sodium depolarizes this area and this area will become repolarized, and when this area is depolarized and this depolarized sodium which coming inside, it depolarizes this area and this depolarized area will become repolarized, and so forth. So what we have seen in the cell membrane of the neuron and the muscle, there is a wave of depolarization followed by the wave of repolarization, which is ultimately the nerve impulse, that is the electrochemical changes that travels along the cell membrane. Now comes to the terminal points. Terminal points, there is a vesicles present. We will discuss these vesicles later in synapses lecture. Just remember, these are the vesicles, and vesicles contain the neurotransmitters. When this nerve impulse come here, it depolarizes this area. Now terminal regions are very specific. There is a calcium channels also, there is calcium pumps also. Usually calcium concentration is more outside, remember, and inside is less. When the adjacent action potential comes to the terminal point, it depolarizes this area, then the calcium channels will open. Calcium channels will, calcium pump will start working, or calcium channels will open. Calcium pump will start working as it throw the calcium outside constantly. But action potential will come at this region, the rather opening the sodium channel, and now this time calcium channel will open and calcium will come inside, and this calcium, if just suppose this is the calcium, it will bound with the vesicles or moving the assist the movement of the vesicles that bring the vesicle near to the membrane of the synaptic knob, which fuses with the synaptic membrane and then they release the neurotransmitter, and then we can say this is the synapses, we will discuss later. So ultimately at the end of the neuron there is a calcium channels, calcium pump also. Whenever this part is depolarizes, calcium channel open, calcium inside, it will modulate the you can say the vesicles, movement of the vesicles, then will fuse with the membrane of the synaptic knob, release the neurotransmitter which stimulate the adjacent neuron, and the story goes on like from tip to the head in a fractions of the second. Now in a nutshell, what we have learned, resting membrane potential and the action potential. In resting membrane potential, cell is not conducting, not excited, it is simply the resting, and almost all the cells follow the resting membrane, has the resting membrane potential. During the resting membrane potential, cell inside more electronegative, cell is only permeable to potassium. Now action potential, whenever you stimulate by any mean, the little potassium inside come or sodium inside come and enough to bring the RMP to the threshold value, then suddenly the sodium channels open and the positive ion or sodium ions rush inside, bringing the neutralize or depolarize the membrane up to the positive 20, positive 30, and then when the reaches up to the maximum high, suddenly the sodium channels off and the potassium channels, gated potassium channels open, and it will repolarize the state. By the delay of time, it will a little bit shoot out from the resting membrane potential and hyperpolarize the state, and then suddenly they off and then recover the RMP. So that during the action potential, cell is become more positive inside and is permeable to the sodium. And remember, the action potential of cells follows the all or none principle. Now, what is this all or none principle? Remember, now look here, focus it. Actually, whenever we took the RMP up to the threshold value, if this is not enough stimulus, like it is the still sub threshold value, there is no action potential. We cannot say that if I touch little, there is a little action potential. If I touch higher, there is a bigger or larger action potential. This is not the case. Actually, action potential across the membrane, the frequency of the action potential might be the high, but the amplitude of the action potential is same, like the voltage are the same. So, all or none principle is state that if you touches the threshold value, there is action potential spread over all the membrane. So, this is all or none. This is either none, like if you cannot touch the threshold value, there is no, like if you can say I brought the minus 90 up to the minus 80, and minus 80 is not the threshold value, you cannot say there is a little action potential, not at all. There is no action potential simply. Even though if there is a minus 75 threshold value, at minus 76 there is no action potential. It should be the minus 75, then there is action potential, and the action potential frequency, amplitude, size, time will be the same across the particular cell membrane. So, this is the action potential. In the next lecture, we will see the synapses, how the neurons talk with each other.